Hello students, today we are going to discuss about molecule. First of all, let us understand that what is a molecule. So, a molecule is made up of two or more atoms bonded together. A molecule is the smallest unit of a chemical compound that can exist. Normally, atoms are reactive. Why they are reactive? Because by reacting, they want to gain stability. And therefore, because they are reactive, they do not exist independently. However, there are some exceptions. Exceptions of noble gases. That is helium, argon, krypton. Actually, noble gases are helium, neon, argon, krypton, xenon and radon. So these are noble gases and they do not generally react at normal conditions. And these noble gases can exist independently. But other atoms like carbon, nitrogen, oxygen, hydrogen, fluorine, chlorine, they all are found in combined states. So the atoms can be same like in the case of oxygen, nitrogen, chlorine, sulfur, or the atoms can be different in elements. For example, in the case like sulfuric acid, hydrochloric acid, water, ammonia. So they get bonded together by strong forces. These strong forces are actually known with the name of bonds, and broadly there are two kinds of bond: ionic bond and covalent bonds. Ionic bonds are formed by the transfer of electrons and covalent bonds are formed by the sharing of electrons. So, molecule is the smallest part of an element or compound. If it is talking about element, it is talking about same kinds of atom. You can say same atoms. If compound, then different atoms. That has all properties of that element or compound and can exist independently. So, it is to be noted here that molecule can exist independently. Molecules are of two types. Molecules of elements when the atoms are same, and molecules of compounds when the atoms are different. Now we come on the molecules of elements. When we are talking about elements, we are going to discuss that element molecules are made up of two or more atoms of the same element, or you can say same kind of atom. For example, hydrogen. Hydrogen is having only hydrogen and hydrogen atom. However, it may contain a proportion of some isotope of hydrogen, but overall it is composed of hydrogen and hydrogen, that is similar kind of atoms, and is formed by the combination of two atoms of hydrogen. It is written here. Similarly, we have molecule of oxygen, that is the combination or association of two oxygen atoms, and ozone, that is three oxygen atoms. It is to be noted that ozone is less stable in comparison to oxygen. And the number of atoms present in a molecule of the element is called its atomicity. For example, hydrogen is there. There are two atoms of hydrogen. Therefore, its atomicity is 2. In oxygen, the atomicity is 2. In O3, ozone, it is 3. Similarly, sulfur exists in S8. Here there are 8 sulfur atoms. Therefore, the atomicity is 8. Why this is happening? That same kinds of atoms are reacting. Just now we have seen the example of hydrogen, oxygen and sulfur. These all are non-metals. So the atoms of most non-metals combine to form discrete molecules like chlorine, fluorine, sulfur, acid, oxygen, ozone. Such molecules contain two or more atoms. The example of two atoms is chlorine, fluorine, oxygen, but the more atoms like F8O3 of the element. Gases like hydrogen, oxygen, nitrogen and chlorine exist as a diatomic molecules. So the molecules having two atoms are known as diatomic molecules. Three atoms means triatomic. So O3 ozone is triatomic because its atomicity is 3. Phosphorus has many forms like white phosphorus, red phosphorus, which are actually the main forms, yellow phosphorus. Here we are going to discuss about yellow phosphorus. So yellow phosphorus forms discrete P4 molecules. Here now you can see that phosphorus is associated in the form of 4 atoms, each molecule containing 4 atoms of phosphorus. Thus atomicity of yellow phosphorus is 4. Similarly, we have discussed the case of sulfur. Carbon. The carbon is found in the form of diamond, which is a 3D structure, and graphite, that is a 2D and a layered structure. So in these big structures of diamond and graphite, many carbons are associated with each other. Therefore, in that same case too, carbon is found in associated form, or you can say in giant molecular form. Similarly, buckyballs are found in which carbon is associated in the group of 60. We have discussed about non-metals. Now we come on metals. In metals, very large number of atoms are closely packed as crystals. These crystals are known with the name of lattice. Thus, atoms of metals form large aggregates and no discrete molecules exist, because in this lattice, actually single atoms are found arranged at different places, just like this. This is the case of metal. Therefore, molecules, discrete molecules doesn't exist in the case of metals. But in case of non-metals, what happen? Suppose this is the case of non-metal, atoms in associated state are found. So, molecules are found in non-metals. Now we come on the molecules of compounds. Suppose a molecule is formed like this. It is containing all green balls, so it is molecule of element. But in another case, suppose it contains 2 green and 1 blue ball. Now the atoms are changed. It contains more than one type of atom. Therefore, now it is molecule of compound. So the atoms are different and they are bonded together by chemical bonds, that is ionic or covalent bond. The atoms of different elements are present in definite proportion by mass, that is law of constant proportion. For example, the case of water, that is hydrogen and oxygen is contained in the ratio of 1:8 by mass. Or if you calculate the ratio of atoms, then hydrogen and oxygen are in 2:1. In simple covalent compounds, the constituent atoms are held together by covalent bonds. Covalent compounds are formed by the sharing of electrons. For example, methane, that is CH4. It is a covalent compound. It is formed by the sharing of electrons. There are some examples of covalent compound. Here, the first compound, that is hydrogen chloride, contains one covalent bond and two atoms. Therefore, its atomicity is 2, and hydrogen and chlorine are the constituent atoms. Similarly, in the case of water, there are 3 atoms. Therefore, the atomicity is 3, and oxygen and hydrogen are its constituent atoms. Similarly, in the case of carbon dioxide, this is the structure of carbon dioxide. There are again 3 atoms. Therefore, the atomicity is 3, and carbon and oxygen are the constituent atoms. In the case of ammonia, nitrogen and hydrogen as its constituent atoms, and there are in total 4 atoms. Therefore, it is tetraatomic, that is 4 atoms are there. CH4, that is methane. It contains carbon and hydrogen as its constituent atoms. It contains 5 atoms in total. Therefore, it is pentaatomic. Having 2 atoms is known as diatomic. Having 3 atoms is known as triatomic. Having 4 atoms is known as tetraatomic. Having 5 atoms is known as pentaatomic.